All right, team, welcome to today's explainer. We're doing something huge today. We're engineering zero defects, and honestly, fundamentally changing the manufacturing landscape. And joining us as always is our lead expert here at Idea Mechanics, our innovation catalyst. You can see him right over there in his signature red shirt, glasses, and that silver-accented hair. He's going to be guiding us through the architectural blueprints of innovation. So let's dive right in.
Now, before we hit the factory floor, we've got to completely dismantle a super common myth. People so often think that innovation is just this random eureka moment, right? Like a sudden stroke of genius that just hits you out of nowhere. But as our catalyst points out, true innovation is actually a rigorous science. It's this highly repeatable architectural discipline known as TRIZ systematic discovery. It directly solves those everyday contradictions to actually engineer innovation. Zero luck required. It's really about building a rock-solid bridge between abstract ideas and practical execution. We aren't just guessing here, guys. We're engineering solutions right from the ground up.
If you're ready to stop relying on luck and start mastering systematic discovery, hit that subscribe button to join the Idea Mechanics team. And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you. Drop a comment below and tell us which TRIZ Principle or tech challenge we should tackle next.
Okay, let's get into the core of today's deep dive. Just look at this brilliant comparison our catalyst is showing us. For decades, manufacturers have been stuck in what we call the blind production trap. The old way? Well, it relies heavily on trial and error and manual visual checks by human operators. It's notoriously slow, it's incredibly subjective, and let's be honest, it is highly prone to human fatigue. We all get tired. Contrast that with the new way, systematic, intelligent quality control. We're talking about moving from a chaotic, reactive environment to a system that is instant, automated, totally non-contact, and brilliantly self-correcting.
So here's the absolute crucial point. Waiting to manually find a defect, that means the waste has already occurred. It's too late. Think about the massive contradiction we face on modern production floors. High-volume production demands incredible speed and massive throughput, right? But that sheer speed heavily contradicts the accuracy of mechanical or human checking. By the time a human inspector spots a flawed product way down at the end of the line, man, the time, the energy, the raw materials, they've all already been wasted. We aren't really preventing errors at that stage, we're essentially just sorting through the garbage. We absolutely need a systematic way to solve this contradiction.
And this is exactly where we turn to the first of our two architectural pillars for today. Notice our navigator over there highlighting TRIZ Principle 28 on the data screen, mechanics substitution. This principle challenges us to replace a physical or mechanical system with a non-mechanical alternative. Think optical, acoustic, or electronic systems. To solve our massive manufacturing contradiction and finally break out of that blind production trap, we absolutely must replace slow physical contact and human visual checks with automated optical sensors.
This perfectly illustrates what we call the digital eye, which means vision systems. Instead of relying on a tired human operator, a high-speed camera captures an image of the product as it literally races down the line. A computer then uses image processing algorithms to instantly analyze it for defects. We're talking scratches, dents, incorrect dimensions, you name it. And what's truly transformative about this outcome is that it's high-speed, non-contact, and completely non-destructive. Manufacturers can suddenly achieve a 100% inspection rate of all products. It completely removes the bottleneck of human capability, guaranteeing consistent quality and massive throughput. It's a flawless, real-world execution of mechanics substitution. But hold on, seeing the defect just isn't enough. The system actually has to automatically adapt. Because we have another big hurdle to overcome here. Even if you have the absolute most perfect high-speed vision system in the world, you are still just being reactive if it only catches defective products right at the very end of the line. The digital eye is an amazing tool, sure, but without a brain to process and act on that visual data in real time to adjust the machinery, we're still letting waste happen.
So to bridge that gap, our innovation catalyst is introducing our second pillar, TRIZ Principle 23 feedback. This principle is all about introducing a mechanism to monitor the output of a system, and then using that continuous data to adjust its operation in real time. If the vision system is our digital eye, then Principle 23 is how we give the machine a fully data-driven nervous system. It's that architectural bridge between just looking at a problem and actively, automatically fixing it.
Let's see exactly how this works in practice. See how our navigator is pointing to this continuous loop? That's Statistical Process Control, or SPC. This is how feedback really comes to life on the factory floor. First, we use our digital eye to collect real-time production data right as the items are being made. Second, the system uses control charts to track performance and detect any process drift. It's actively looking for trends that show the machine is just starting to fall out of alignment. And third, the absolute magic step. It auto-corrects the system before defects even occur. It literally fixes the alignment before a single piece of waste is created. It's completely proactive.
Now, what's truly powerful here is how beautifully this all synthesizes together. When we combine automated sight and self-correction, we completely bridge the gap between abstract quality goals and actual practical execution. Looking at the top, Principle 28 gives us the digital eye through high-speed vision systems, which gets us that 100% automated inspection. Then, looking at the bottom, Principle 23 gives us the nervous system through statistical process control, giving us real-time self-correction. By combining these two TRIZ principles, we aren't just putting a Band-Aid on an old process. We are architecting a completely new paradigm for intelligent manufacturing.
So the big fundamental takeaway for you today is this. Flawless quality is engineered. It is not inspected. True manufacturing excellence is a repeatable architectural skill that gets built directly into the process itself. We really have to stop accepting the limitations of human inspection and blind machinery. We just can't achieve zero defects by trying to inspect the flaws out at the very end of the line. No, we achieve it by systematically engineering intelligence right into the very heartbeat of our production.
Which leaves us with one final, incredibly important question to ponder today. Look at your own workspace. What outdated blind process in your facility desperately needs a digital eye and a nervous system today? I really want you to take these architectural mindsets, these systematic TRIZ tools, and go apply them to your own production floors. There is absolutely a blind process out there right now just waiting to be illuminated by systematic discovery. Thank you so much for joining us for this explainer team, and keep engineering those solutions.